Hello, everyone. In this video, we're going to continue our work in section 8.1 by looking at example 3. In this video, we're going to cover part A. In all the three parts of this example, we're looking at different sequences, and we're going to be asked to determine whether the sequence converges or diverges. If it does converge, then we need to find the limit, and we need to justify our answer. All right, so let's go ahead and get started by looking at part A. So this sequence, ln over n, can be written if we want to create the list as ln of 1 over 1, ln of 2 over 2, just to get a sense of what is actually going on here in these numbers, ln of 3 over 3, etc. And so then we want to ask the question, do these numbers converge or diverge? Or maybe not approach any particular number. So if they diverge, they'd blow up to infinity, but if not, they could just switch back and forth from like -1 to +1, etc., or they could converge to a number. And we can get out our calculator and compute what these numbers actually are. So ln of 1 over 1 is just 0. And then we can compute, we can get out your calculator if you want to follow along with me. But then we can compute ln of 2 over 2. And we get 0.34657. 57. And then if we plug in 3 here, we get ln of 3 over 3, and we get 0.3662. But again, just looking at a few finite numbers is not going to give us the solution about whether this sequence converges or diverges. So to do that, we need to set up the limit. So we're going to set up the limit as n goes to infinity of ln of n over n. So notice what happens is n blows up, this ln of n, that will also blow up. So this will go to infinity. N will go to infinity as n goes to infinity. So what we want to use is L'Hopital's rule. So I'm going to use an h over that equal sign to justify why these two things are equal. Equal to the limit as n goes to infinity of, well, now derivative of numerator. So recall derivative of ln. What was that again? We need to look it up. Just 1 over n. Then derivative of 1 is just 1. So this becomes the limit we can simplify as n goes to infinity of just 1 over n. Because when you divide by 1, that numerator just stays the same. So we have the limit as n goes to infinity of 1 over n. Well, what happens there? As n goes to infinity, the denominator blows up. 1 just stays the same. So this overall fraction gets smaller and smaller. So we end up with 0. So notice when I'm writing out this sequence of equals, I'm always including this limit each time. Because it's not true that this entire starting limit is just equal to 1 over n over 1. We're looking at the limit always until we reach something like this last part where we know what this limit actually becomes, and that is 0. All right, so what can we say then? Well, using this work, we see that therefore, these little 3 dots represent in math, therefore, the sequence converges to 0. So if we continued writing out these numbers, we'd get closer and closer to 0. And in fact, you could give me a challenge number, like get this close to 0, and then I could give you an n where we are that close to 0 in the S sub n. All right, great work. So feel free to rewatch any parts of this video and then move on to part B.